Welcome to this session. Now we are going to discuss an economic analysis of financial regulations. So, in this theme, in this area, the subtopics that we are going to cover: why financial regulation is important, what all makes financial regulation relevant, and in order to regulate financial sector, what all the tools are being used by the regulator. These are all the themes that we are going to discuss. So, to begin with, first we are going to discuss why is regulator, to examine why is regulators use value at risk as the measure to minimize investment risk. So, that is to minimize the investment risk, that is one of the objective of regulations. So, in this context, why regulators use value at risk as the measure. So, in this way topic we further discuss this theme by what is meant by risk in the case of investment risk, what is meant by investment risk, and then we will discuss some of the statistical measure used in analyzing or measuring investment risk. Then there we will see what kind of measure regulators are interested to use, and then subsequently we will discuss other kinds of risk, that the systematic and idiosyncratic risk, and some of the strategies for risk reduction including hedging and diversification. So, coming to the first part, investment risk is a measure of uncertainty about the future payoff to an investment assessed over some time horizon and relative to a benchmark. So, it has several features, the characteristics of investment risk when as per our definition. So, one, you know that is a measure that can be quantified, that is one. Second one is risk arises from uncertainty about the future, and the third one is risk has to do with the future payoff of an investment which is unknown. So, that means the future payoff in most investment is uncertain, right? That is what is all about the investment is going to make is riskier. So, that is the third aspects, and the fourth one is that risk refers to an investment or group of investments. So, that means the term investment here broadly include everything from the balance in a bank account to shares of a mutual fund to a lottery ticket and real estate. So, these are all investments that we refer here. Risk must be assessed over some time horizon. Every investment has a time horizon. We hold some investment for a day or two and others for many years. So, in most cases the risk of holding an investment over a short period is smaller than the risk of holding it over a long one, but there are important exceptions to the rule that we will discuss sometime in the one of the later session. Finally, risk must be assessed relative to a benchmark rather than in isolation. So, someone tells you that an investment is risky. So, normally we say that relative to what? Investment is risky, but relative to what? So, that is another important area, that the relative to an investment with no risk at all, that is the benchmark that we will be using. That means the benchmark is a risk free investment. Let us now discuss how to measure risk. So, since now you are familiar with the definition of risk, what is meant by investment risk. So, let us see what are the approaches of measuring risk. So, in the case of measuring risk, there are three aspects. One is possibilities, and second one is probabilities, and the third one is expected outcomes. So, about the possibilities, you know that what are the possible outcomes when you make an investment. So, it can be explained by using the example of tossing a coin. So, when you toss a coin, so what are all the possible outcomes? Obviously, you know that there are only two and only two, right? That means the two possibilities because the coin can come down either heads or tails. So, that is the possibility, two possibilities here we just mentioned. Similarly, for investment there will be several possibilities will be there, so that we will discuss in appropriate context sometime, some in this session itself, some in the future sessions. Then coming to the second aspects, probability. What is the probability? So, taking the same example of the coin, that what is the chance of each one of these two outcomes occurring. So, if the coin is fair, it will come down heads half the time and obviously tails the other half. That is what we mean by fair here. So, if we toss a fair coin over and over again thousands of times, millions of times, it would come down heads half the time and tails other half. So, for any individual toss, the coin has an equal chance of coming down heads or tail. So, when we quantify here, you know that this is the probability of head coming up is going to be 0.5, that the half, 50%, 0.5 is the probability, and tail obviously you know that is also 0.5, that the half, 1 half. So, this is the probability. So, probability means, as you may be aware, that actually is a measure of the likelihood of an event will occur. So, it is always expressed as a number between 0 and 1. So, closer the probability is to 0, the less likely it is that the event will occur. So, that is about the probability. Then the outcome, here we know already, that means the outcome is head and another outcome is tail, heads and tails. So, then coming to this possibilities, that there are two possibilities and these are the two probability, that is 0.5, 0.5. The outcome is heads and tail. This is a simple example by using the example of tossing a coin that we are also familiar. So, let us apply this one in the context of investment. So, what are the possibilities, probabilities and outcomes, and plus we need to include when you invest there is an expected return as well, that also we need to include when we elaborate this example. So, in order to discuss this, let us take the case of two alternative investment scenarios of $1,000. So, throughout this discussion, let us take an investment of $1,000 with expected return of 1050. So, that the same expected return we are getting from two alternative investments. Then in this case, let us see how we can relate it with the possibilities, probability and outcomes. So, let us take the case one investment, assume that for 1000 you can purchase a stock whose value is equally likely to fall to 700. That is one possibility, that with a probability of 0.5, when you invest 1000 in a stock, maybe when the stock market down, it can go down to 700. So, the stock value equally likely to fall to 700, that is one possibility. Another outcome is going to be, it can rise to 1400. So, we will refer the amount you could get back to as the investment is payoff. So, what is the payoff here? The payoff here is the probability, right. So, the probability of becoming that falling the stock price from 1000 to 700 is 0.5. So, the payoff that you are going to get is 700, then the payoff times probability is going to be 0.5 times 700, that is $350, right. So, that is in the case 1, that the possibility 1. In possibility number 2, when the stock price increase, the payoff is 1400 and the probability of getting that one is 700, right, that the payoff times probability. So, in this case, let us see in this we need to calculate now the expected value of the investment. It is straightforward, you know that expected value is the sum of the probability times the payoff. That means this plus this, that means when summing you will be getting 1050, that is the payoff. The expected value of the investment from this investment is 1050. So, normally in general the expected value concept, that the expected value of an investment is a very useful concept, but it can be difficult at first. The problem is that if we make this investment only once, we will obtain either 700 either we will get either 700 or 1400, not 1050, right. We won't be getting these 1050 ones. However, in fact, regardless of the number of times we make this particular investment, the payoff will never be 1050. It is never going to be 1050. But the relevancy here is that what would happen if we made to make this investment 1,000,000 times. Maybe 500,000 times those investment would pay 1400, another 500,000 times we will get 700, right. So, at the end again we are going to get, if you do the calculation, then obviously we are going to get the expected value 1050. So, however, that actually, since the future is uncertain, we do not know exactly how much will be the payoff. So, since there is uncertainty, in that context actually we can use this expected value as one of the measure to understand what is the outcome of the return, possible return from the investment. So, in this case, from what are the measures that are commonly used to measure this risk? For example, in this investment, what are the measures of risk that we can use? Commonly, there is one measure that is very commonly used to measure the risk of an investment. So, one of the measure that is actually variance and standard deviation. So, in the case of variance, variance is defined as the average of the square deviations of the possible outcomes from their expected values weighted by their probabilities. Let us take the example that which we just mentioned now. The two cases, of the one case we already discussed, that is this one. The case one is investment of 1000 with an expected value of 1050, and out of this let us calculate the standard deviation of this investment. So, how to calculate? I think you must be familiar with this kind of concept. So, let us have a quick review of how to calculate the standard deviation of this investment. So, what you need to do, the expected value is this times this, that is 1050. First calculate the expected value, then calculate this one, that subtract the expected value from each of the possible payoff. That means one actually 1400 minus 1050 is equal to 350. That is one in the process, that is one first one step. Another, we need to calculate 700, that is the payoff, minus the expected value, that is 1050 is equal to minus 350. So, then the procedure for calculating SD here is, first the variance calculation, square each of the results, that the 350 square. So, that means you will be getting this and this. So, square each of the results and multiply the results times its probability and add up the results. So, finally, you will be getting this as the square of each results. Then calculating the standard deviation is SD is equal to the variance, square root of variance, then you will be getting this one is equal to 350. So, in this case you can see that the standard deviation is going to be 350. Let us now take another example, another case, investment case 2, where the scenario is, if the investment is same 1000, and again we are going to get the same expected value here as well, 1050. Let us see the payoff, the standard deviation of this investment. So, standard deviation of this investment, again we have here, we take 4 possibilities, number 1, number 2, number 3, number 4, and the probability we are having these values. And the payoff in one investment, suppose the same, for example, you are buying a stock, you are going to get the stock price from 1000, it may fall down to 100, that means you are going to make a loss of 900, and it may go down to 700, it may rise to 1400, and if there is a huge bull in the market, then the bullish market, you can see that it can go up to 2000. So, these are the 4 payoff, then the payoff times probability that we can already calculate from here, then you will be getting these values. So, in this scenario, how do we calculate the standard deviation? So, the standard deviation you will be getting the stuff that we discussed already, payoff minus expected value, then you will be getting these values, payoff minus expected value square, then the variance is the sum of probability times square deviation of the payoff from expected value, that is going to be this times 0.1, this times 0.4 times 0.4 again times 0.1, this one. Then what are the value that we are getting? We need to add this one together. Maybe we can say that here the variance that you are getting here is variance here is equal to sum of probability times times square deviation of payoff from expected value, that we will be getting 0.1 times 902 500 times then plus 0.4 times 1000 to 122,500 plus 0.4 times 500 plus 0.1 times 92500, then you will be getting the value that we will be getting from this calculation is 278,500 dollar square. This is the value you are going to get. So, the standard deviation of this one, that this is the value that you are going to get. So, the standard deviation of this one is going to be 528. So, let us look at the previous case that we got the standard deviation of 350 from this investment, and in the second investment we are going to get a standard deviation of 528. So, looking from these two investment, one is having a standard deviation of 350 and the another is having a standard deviation of 528. So, normally a firm, an investment fund, they will be preferring the investment strategy of case 1. In fact, this one they will be preferring because the standard deviation, the risk spread is low, and they will be preferring this investment. This is from the perspective of an investor or an institutional investor, for example, but from the perspective, this is the most common measure of risk, but in the perspective of regulator, we need to take a different approach of measuring risk. This may not yield the correct measurement of the risk. Let us see why. So, because here suppose the risk is very low, but at the same time, you know, sir, that means, for example, no one is interested in a discount price for a life insurance policy from an insurance company that is poor financial conditions. No one wants the local bank to close its door, even if it's giving the standard deviation, the measure that we are getting is very low and is giving high payoff. But similarly, neither the customer nor the government regulators care how well or how badly a financial institution shareholders fare, so long as they do well enough to keep the doors open. So, in this case, suppose if there is the means, for example, what if the insurance company collapse? What if the bank collapse? So, that means the catastrophic loss, right? That is a catastrophic loss. So, even no one individual investor, institutional investor or government, they do not want to see that kind of outcome, that the worst outcome they do not want to see. So, in this case, the concept used to assess this sort of catastrophic risk is called value at risk. So, let us examine how the concept called value at risk work. So, to understand this one, let us take an example of that you are considering buying a house with a loan of 1 lakh. Let us take this example, and given your economic condition, you can afford an EMI of $650. The assumption here is that you cannot afford, given your salary pay conditions and all, you can afford maximum 650 EMI per month. So here the question is the type of mortgage. What kind of mortgage? Suppose you find a nice house and you want to buy and you can afford only 650, but when you want to take a loan, you need to decide on the type of mortgage to get. So should it have a fixed or flexible rate, the adjustable rate? So the answer is different for different people. So in your case, let us see if we can organize our thinking with regard to this example and see and clearly that this person cannot afford more than 650 per month. Then in this case, let us see, take the case of a mortgage loan. Mortgage loan with an example that for example for a 30-year term loan. So in the case of a 30-year term loan, one alternative is a fixed interest rate, that is 4% per month. So the 4% interest rate, the EMI, accordingly the EMI coming is going to be 475. That is a monthly payment of 475, which is within this person's budget, because maximum he can afford 650. So the one alternative here is alternative 2 is a 3% flexible interest rate, that the starting interest rate is 3%, but the concern here is that this interest rate is flexible. That means it may go up or it may go down. So in this case, if there is no change, actually this is the flexible interest rate. That means when the market interest rate goes increase, then this interest rate will increase to 4%, 5%, 6%, like that. So suppose if the market rate is going to be same, there is no change in market rate of interest, then the EMI is going to be 420 to start with. So you know that in the case of investment 1, you know that the standard deviation is 0, right? Standard deviation is 0. In the second case, obviously you know that we don't know exactly how much is the standard deviation without getting what is going to be the market rate of interest, but obviously we know that is going to be greater than 0, because there is a possibility that market rate of interest will change. So obviously there is possible variation in interest rate over 30 years. So two scenarios. One, what if no change in interest rate? Then obviously you know that if there is no change in interest rate, alternative 2 is the best option, because instead of going for a simple calculation, instead of going for 4% fixed interest rate, it is better to go for the lower rate 3%, provided that there is no increase in interest rate. Even if it decrease, if going to 2%, then is even further even better, right? Even better. What if it keep on increasing? So think about the scenario, what if the rate of interest increase? But that means if the rate of interest increase, that means this is the risk. Risk is here mainly when the rate of interest increase. For example, when it goes to 10%. So that initial monthly payment, okay, fine, it looks attractive, but when we know that when the rate of interest keep on increasing in the market, suppose initially raised to 2%, suppose the interest rate could raise 2% per year for the next 4 years. That means suppose the rate of interest R is going to increase to every year is going to increase 2%. So then you know that the risk is that the initially first year you need to increase pay initially the 535. If you take the rate of interest is not 3%, instead if you take 5%, is going to be 535. Second year if it goes further, then you are going to pay 665, and if it goes further, then third year you are going to pay 800, right, is keep on increasing. So that means if the 2% increase in the rate of interest per annum, when we opt for flexible, you know that the EMI is going to become, in the third year EMI is going to become 800. So you already seen that this person can afford only 650. What if it further increases? You know that if keep on increasing, then this person's actually all his plans actually it get all derailed, and you know that he will be sometimes he may lose even his mortgage house because he cannot pay back. So, in this case what we can see that this kind of scenario, sometimes this worst, the rate of interest can go to 10 percentage, then even the worst case is happening, right. So, that actually the concept that we are going to discuss here, that is called the concept of value of risk. So, look at here these two investment, in the two investment, look for example, suppose investment, that is case 1. So, in case 1 you can see that the worst case, there are two possibilities, one is 1 2, you can see the payoff, one with the payoff 700, the person invests 1000, that is the example we have taken, but the stock value can go down to 700. Then second option is that second possibility is that the stock price can increase to 1400. So, look at the case 1, if the going down, the worst case of loss here is this one, that means he invested 1000 but it became 700. So, the worst loss in case 1 is 300, and in case 2 the worst case, there are the 4 possibilities. The payoff in each possibilities, each outcome, you can see that 100, 700, 1400, 2000, etc. What if the worst loss happening, because either of this one will happen. Suppose the worst loss is, for example, this outcome, the possibility 1 happens, then the worst loss, that the investment is 1000 but the payoff is only 100, then the loss is going to be 900. What if this investment, instead of an individual investor, look at take this one, for example, the case of an institutional investor. For example, a pension fund has invested this, made this kind of investment, and you know that in this case, the case 2, you can see that this the worst case loss is more with the case 2, right. And suppose we add this one, instead of this 100, that 900, this one, if you add million after it, suppose these are all million or billion dollars, then actually it matters. So, when it comes to this part, value at risk is the worst possible loss over a specific time horizon at a given probability. So, in this case, value at risk is this 900 is the value at risk, that means the payoff, this one, this is the value at risk. Using the value at risk, we can see that case 2 is the worst one as compared to case 1, because here the maximum loss is 300 in case 1, but in case 2 the maximum loss is 900. So, let us summarize this concept. So, the value at risk is the worst possible loss over a specific time horizon at a given probability, and especially this measure we will find very useful in discussing the management and regulation of financial institutions. So, by restricting the source of financial instruments bank can hold, bank managers, financial regulators try to limit the chances of financial collapse. So, importantly, such a collapse is an example of infrequent but potentially catastrophic event, sometimes called tail risk or black swans. For example, enormous earthquake. The earthquake happened in Gujarat. Similarly, similar events. Similarly, when you approach this one, put this one in the investment case, if there is a huge loss, or even an insurance company insuring some uninsurable risk, that actually the regulator won't allow. So, simply to summarize this one, what we do that actually regulators especially use this concept, that the value at risk, when they advise, when they look at the different investment strategies of investment funds, for example, particularly public funds including pension funds, etc., regulator take a look at the what is the maximum worst case of loss, that kind of investment won't be encouraged. And in the next session, we will continue some more discussion of some more concepts related to risk, and subsequently we move to more making what are the rationale for regulation in the financial market. Thank you, and see you in the next session.